let's just discuss about what are the exponents and what are the base. So let us suppose we are talking about what is the meaning of an exponent and what is the meaning of the base. So for any a raised to the power m representation, for any a raised to the power m representation, a is always called as the base and m is called as the exponent. So for any representation which is of the type a raised to the power m, a raised to the power m, then a is always called as the base. As for a raised to the power m, a is always called as the base and the power, or we can also call it as an exponent, where the m is called as the exponent and we can also call it as the power. So a is called the base and m is called the exponent. So for a raised to the power m representation, there are various laws. What are those laws? Let us suppose we are talking about the very first law, which says that if we have a raised to the power m into a raised to the power n representation, a raised to the power m, a raised to the power n, where bases are same. The base over here is a, the base over here is a. Whenever the bases are same, then the powers or the exponents gets add with each other. It means that for a raised to the power m, a raised to the power n, the representation is a raised to the power m plus n. This is the first law of exponent, in which always remember, whenever the bases are same, then the powers always get adds up whenever they are get multiplying with each other. As a raised to the power m and a raised to the power n are multiplying with each other, both of them have the same basis, then it will be a raised to the power m plus n. So let us suppose we are moving on to what the second law of the exponent, which says that a raised to the power m whole raised to the power n. Let us suppose we have two powers, one is the m and other one is the n. So whenever I'm saying power, it means I'm talking about the exponent. So here we have two exponents, m and n, where m is inside the bracket and n is outside the bracket. So whenever we have such kind of a scenario where a raised to the power m is raised to the power n, then this can also be written as a raised to the power m into n. Powers or the exponents always get multiplied with each other. Let's move on to what the third law of the exponent, which says that a raised to the power m divided by a raised to the power n, where the bases are same again. In all these three laws, bases were the same. So for a raised to the power m divided by a raised to the power n, whenever we have such kind of a representation, always remember the powers or the exponents always get subtracted with each other. Means a raised to the power m minus n, where always remember m is greater than n. So this is the basic representation or the basic law of the exponent. So let's just move on further. We are talking about the fourth law of the exponent, which says that whenever the bases are different from each other, a raised to the power m, b raised to the power m, the bases are different. Here the base is a and here the base is b. So whenever the bases are different but the powers are same, then the bases always get multiplied with each other and the power will be like this. So a raised to the power m, b raised to the power m can be written as ab whole raised to the power m, because both of them have the same common power as m and m. So m will be like common outside the bracket. So these are the four laws of the exponents with the help of which we can able to solve any particular questions for the laws of the exponents for the real numbers. So let's just move on further. Further we'll talk about the extended laws of the exponents. What are the extended laws of the exponent? Those four laws were the basic laws of the exponents, which we have already discussed about, but this is the extended laws of the exponents. What are those? So let us suppose we are talking about for any a real number, let a greater than 0 be a real number and p and q are any rational numbers. Now we will take the exponents as the rational numbers. So let us suppose we are talking about a being a real number and p and q be the rational numbers, then a raised to the power p, a raised to the power p, q can be represented as a raised to the power p plus q. So actually we are using the basic laws of the exponents, but we are now calling them as an extended laws of the exponents because we are using the powers as the rational numbers p and q. So the very first law say a raised to the power p into a raised to the power q, where a is a real number and the basis of both of these numbers are same, and the powers p and q, they are nothing but the rational number. So a raised to the power p, a raised to the power q, when are getting multiplied with each other, then their basis always remain the same, but the powers always get adds up. So p plus q, the answer is p plus q. Let's just move on toward the next law, which says that a raised to the power p divided by a raised to the power q, a raised to the power p divided by a raised to the power q, as the base is same, so the powers subtracted with each other, the answer will be a raised to the power p minus q. Always remember p and q can be any rational number over here. Let's just move on toward the third law, which says that a raised to the power p outside the power is q. So powers always get multiplied with each other. So the answer will be a raised to the power pq. So just as same as like that of the basic laws of the exponents, but here we are taking the powers or the exponents as a rational number. So the difference is only this. So let's just move on towards the fourth, which is nothing but when a raised to the power p gets multiplied with b raised to the power p. Here the basis, both of them are different, a and b. So a and b will get multiplied with each other as both of them have the same power as p. So the power will be like this. So these are the four extended laws of the exponents which we will use now in order to solve the questions. So let's just move on further towards the questions. So problems based on laws, in which we have the very first problem which says that simplify. Simplify, you have to simplify first part, which is 2 raised to the power 2 by 3 and 2 raised to the power 1 by 3. This is our very first part in which we have to solve this particular representation. So let's just talk about the second part. The second part says 3 raised to the power 1 by 5 whole raised to the power 4. Whole raised to the power 4. Let's just move on to the third part. It is 13 raised to the power 1 by 5 and 17 raised to the power 1 by 5. Let's just move on further towards the fourth part, which is 7 raised to the power 1 by 5 and in division 7 raised to the power 1 by 3. Now we have to solve all these four parts using the extended laws of the exponent. So let's just move on solving the questions as. Let us suppose we are talking about the very first part. The very first part says that it is nothing but 2 raised to the power 2 by 3. So let us suppose I'll write it again as 2 raised to the power 2 by 3 and 2 raised to the power 1 by 3. So it is 2 raised to the power 1 by 3. As we know that the powers over here, let us suppose we are talking about this particular power and this particular power. These both are nothing but the rational numbers and we have the same base. We have the same base. The base is same. This is our base. This is our base. So this is our base and both of the bases are same. Whenever both of the bases are same and they have the different power, then we have a law which says that. So let us suppose I'm writing it over here, which says that whenever we have a raised to the power p multiplying with a raised to the power q, then it can be represented as a raised to the power p plus q, where the powers always get added up with each other whenever such kind of numbers will get multiplied with each other. So using this particular law, so I'm writing it over here, using this law, we can write it as we know that the base over here is nothing but 2. So in place of a, we have 2. So it can be written as, if a is 2, it can be written as 2, and the powers will get added up with each other. So it will be nothing but 2 by 3 plus of 1 by 3. Now let's just solve the powers. As we know that the LCM of 3 and 3 will be nothing but again 3. So it will be like 3 and 2 gets added up with 1. So it is 2 plus 1 by 3. Now solve it. We get the answer as 2 raised to the power 3 by 3. So 3 into 1 is 3. So the answer is nothing but 2 raised to the power 1, which is again 2. So this is nothing but my answer. So this is my answer. So what is the answer of the very first part? That is 2 raised to the power 2 by 3 into 2 raised to the power 1 by 3. It is nothing but 2. So this is the very first answer. After solving this particular representation using this law, we get the answer as nothing but 2. So let's just move on further toward the second part. The second part says that, let us suppose I'm rewriting it again. The second part is 3 raised to the power 1 by 5 whole raised to the power 4. We know that whenever we have such kind of a scenario in which we have any particular base and there are two powers. The first one is raised to the power 1 by 5. This is our first power and this one is our second power. Both of these are rational numbers. So as we know that for any particular a raised to the power p raised to the power q representation, the powers always get multiplied with each other. So it will be like a raised to the power p into q. So we are actually using this law in this particular point. So let's just solve it. It can be written as 3 raised to the power 1 by 5 raised to the power 4. So p and q, when gets multiplied with each other, it will be like a raised to the power pq. So it can be written as 3 raised to the power 1 by 5 into 4. It can be written as 3 raised to the power 1 by 5 into 4. Now let's just solve the power. So the answer will be like 3 raised to the power 1 by 5 into 4. The answer will be 4 by 5 because 4 when gets multiplied with the numerator, so it will be 4 into 1, which is nothing but 4, and in the denominator 5 gets multiplied with 1, so it will be 5 into 1, which is nothing but 5. So the answer is 3 raised to the power 4 by 5. So this is nothing but my answer, or the simplification of the second part using this particular law. So let's just move on further towards the third part. The third part says that we have the bases which are different to each other and the powers are same. So it is nothing but, let us suppose I'm rewriting it again. It is 13 raised to the power 1 by 5 into 17 raised to the power 1 by 5. As we know that we have the different bases. So whenever we have the different bases, we always remember about using the result. What was the result? Whenever we have the different bases, we have the result as a raised to the power p when gets multiplied with b raised to the power q. As we know that the bases are different but the powers are same. The bases are different, both of these are different from each other. As we have in the first base we have 13 and in the second base we have 17, but the powers of both of them or the exponents of both of them are same. So we can use the law as whenever a raised to the power p gets multiplied with b raised to the power p, so let us suppose I'm writing it as b raised to the power p because we have both the powers as same. It is b raised to the power p, a raised to the power p, then it will be nothing but ab whole raised to the power p. It is nothing but ab whole raised to the power p. Always remember using this result whenever both of the bases are different but the exponents are same, then we can write it as ab multiplication whole raised to the power p. So this can be written as 13 into 17 whole raised to the power 1 by 5. Now we can multiply 13 into 17. So let us suppose I'm solving 13 and 17 over here. 13 and 17, it will be like 51 into 7 and 1. So it is nothing but 1, 2, 2. So it is nothing but 221. So the answer is nothing but 221 whole raised to the power 1 by 5. So this is nothing but our answer. So this is the simplification for this particular part. So let's just move on further towards our fourth part, which says that 7 raised to the power 1 by 5 divided by 7 raised to the power 1 by 3. So let us suppose I'm rewriting it again. 7 raised to the power 1 by 5 divided by 7 raised to the power 1 by 3. And we can use the law as, we know that we can use the law over here as using the result, or you can say using the law. Using the result, or you can say using the law. We know that whenever we have the same base and the powers are different but they are getting divided with each other, so this can be represented as a raised to the power m minus n. We can also write in place of m and n as p and q. We can also write over here as p, we can also write over here as q, because this is also called as the basic law of the exponent, or we can also call it as the extended laws of the exponent. Here I'm taking m and n as any rational number. So let us suppose I'm taking m and n are any rational numbers over here. Let us suppose I am taking m and n are any rational numbers over here. So as we know that we can use this particular law over here because the bases of both of them are same as 7 and 7, and the powers are different as m and n, where m is nothing but 1 by 5 and n is nothing but 1 by 3. So let us suppose I'm writing it as 7 raised to the power m minus n. M minus n. What is m? M is nothing but 1 by 5 minus of n. N is nothing but 1 by 3. So the answer will be like 7 raised to the power 1 by 5 minus 1 by 3. Now let's just solve this representation. First of all, take the LCM. The LCM of 1 by 5 and 1 by 3, obviously it is nothing but 5 and 3. The LCM of 5 and 3 is 15. So after solving it, we get the answer as 3 minus of 5. So the answer is nothing but 7 raised to the power 3 minus 5 is nothing but minus of 2 divided by 15. So minus of 2 divided by 15. We can say this is our answer, or we can also convert it into the positive power. How we can convert it into a positive power? We can take it into the denominator, so the powers will be positive. So it also can be written as 1 by 7 raised to the power 2 by 15. So you can either write it in this formation or you can either write it in this particular formation. So both of these are answers, but always remember to convert the negative powers into the positive one whenever we are simplifying any particular question. So it means that the answer of the fourth part can be 7 raised to the power minus 2 by 15, or it can also be written as 1 by 7 raised to the power 2 by 15. So both of these are answers. You can take any one of it, and this is all about simplifying all such kind of the problems in which we have used the extended laws of the exponent. I hope all the answers are all clear to you. So let's just move on further.